The next section we're going to study are parametric equations. And a parametric equation is completely different than anything you've worked with so far, different than rectangular and polar, in that we're going to deal with three variables in a two-dimensional situation. We're going to add a time variable, and the time variable is going to give us more information about a graph. Let's take a step back for a moment then. Y equals 2/3 x plus 3. You know that this is a line with a y-intercept of 3 and a slope of 2/3. That's still going to be the case in parametric equations. So we're not going to completely flip the way you write xy points when you did with polar, where we completely changed everything. This is actually going to follow xy coordinates. But we want to add an additional variable to represent where something is at a certain point in time. So ultimately what we're going to do is we're going to break this equation down to two equations. So to start, if I were to create an xy chart of this equation, 2/3 x plus 3, I could go through and choose any numbers for x, 0, 1, 2, 3, 4, and then I could figure out the corresponding y values. But for the purpose of this, I'm going to be very strategic in the numbers I choose. I'm going to go up in values of 3. And the reason for that I did is because I've got the denominator of 3 here. And when I plug in values that are factors of 3, it's going to make solving this first part whole numbers as opposed to fractional pieces. So that's the only reason I went in factors of 3 there. If I do that, if I plug in -3 for x, if I plug in 0 for x, if I plug in 3 for x, the pattern I get for y is going to be 1, 3, 5, 7, 9. Nothing new there. The piece that is going to be new, though, is what if I wanted to represent just this column as its own equation, and then just this column as its own equation? And that's what we want to do. We want to write this first column, we're going to write x as its own equation, and then we're going to take my y column and we're going to write y as its own equation. So let's see what that would look like. This x column, there's a relationship there. And I need to come up with a relationship where I can plug in some other variable and solve for x. And I can't use x's and y's because I've got x equal here because these are my x values and this will be my y's. So as I mentioned, we're going to add another variable called time, which is going to be t. So can I come up with a relationship for time here? And the answer is yes. I could say this is 3t minus 3. That's one way that I could represent this x equation. And if I did that, let's say I put in another column here called t, 0, 1, 2, 3, 4. If I plug in the 0 for t, I get -3. If I plug in a 1 for t, I get 0. If I plug in a 2 for t, I'll get 3, because 6 minus 3 will be 3, and so forth. So currently, I am ignoring this y column right here. If I just look at my t and x's, does x equals 3t minus 3 fit the pattern? And the answer is yes. And this t, I just knew ahead of time what I was aiming for, so that's why I chose 0, 1, 2, 3, 4. We'll look in this chapter how you determine what those t values are going to be. But you can see here, I now have a t and an x chart to create one equation. So that's the first part of my parametric equation. The second part then is going to be, what if I covered up this x column like that? And I only dealt with the t and the y. What is the relationship that you see between t and y there? And the relationship that should emerge is that 2 times t plus 1 is equal to y. So 2t plus 1 is equal to y. Cover that back up again. If I plug in a 0 for t, I get the y, which is 1. If I plug in a 1 for t, I get the 3. 2 times 1 is 2 plus 1 is 3. If I plug in a 2, I get a 5. If I plug in a 3, I get a 7. If I plug in a 4, I get a 9. So these two equations are my parametric equations that come from this rectangular equation. So we're going to go rectangular to parametric, which are basically two more rectangular equations, except for one's an x and one's a y, and they both have t's in it. So that's a little background for where we're going with parametric equations. So here's the basic idea. If my scenario was that I was going for a run, what would I want to know for my goal? I want to know my distance, I want to know my position, and I want to know my time. And the graph would look something like a straight line, assuming that I'm running with a consistent pace. The issue is that there's only two variables. I've got an x-axis and a y-axis. And the way that we resolve this, I've sort of already mentioned, is that we assume one of those is constant. And we usually assume that the pace is constant. So then I could do something like this. That's my distance and time graph. So something that's a little bit more complex would be a football player making a cut. Meaning he runs to a position, then changes direction and accelerates really quickly. When should the quarterback throw the ball? And how far has the player traveled? So I could do some sort of position time graph that would look like this. But I'm still restricted here because I've only got two variables in a three-dimensional world. So what we're going to be doing is we are going to be declaring a third variable, which we're going to call time. And we're going to plug that into our calculator and see what we come up with.